Welcome to Wagnerdery. I'm Jake Wagner, and today we're going to talk about the Cynefin Framework. The Cynefin Framework is a decision-making framework developed by Dave Snowden of CognitiveEdge.com in around 2002. The goal of the Cynefin Framework is to give people a framework by which they can figure out how best to approach their problems. So you take whatever situation you find yourselves in, you slot it into domains described by the Cynefin Framework. And based on which domain it's slotted in, the framework gives you an approach you can use to help tackle your problem. So it's not here to tell you solutions to your problems, but it is here to help you understand how best to approach your problems. So, how does it work? Cynefin begins by dividing your situations up into three systems. Systems divided by how we perceive the relationship between cause and effect. Those systems are ordered, complex, and chaotic. An ordered system is a system where the relationship between cause and effect exists, is repeatable, and is predictable. This is a case where you can tell what the effects of your actions are going to be before you execute them. A complex system is a system where there is a relationship between cause and effect, but you can't necessarily predict the effects of your actions in advance. Perhaps there are some unknown agents where you can tell in hindsight that your action caused this effect, but you can't necessarily predict that the same action will cause the same effect in the future. Finally, there's a chaotic system. A chaotic system is a system in which you can't determine what the relationship between cause and effect is, either in hindsight or foresight. This is a situation where perhaps even the scope of the problem isn't fully known, let alone how to get to the root of the solution. What the Cynefin Framework does next is it divides these three systems up into 5 domains. Ordered systems get divided up into 2 domains, obvious and complicated. Complex and chaotic each get their own domain, and there's a 5th domain, disorder, which indicates the state that you're in whenever you don't know which of the other 4 domains your situation puts you in. Now, let's look in a little more detail how each of these 4 domains work. The obvious domain is the first of our ordered system domains. As an ordered system, we know that the effects of our actions is something that's predictable. What makes this domain obvious then is that the effects you're predicting, the predictions you're making, are predictions anyone could make. The effects of your actions are obvious to everyone. For that reason, the approach we can take to any situation that slots on the obvious domain is sense, categorize, respond. We sense the problem that we're having. We categorize it, we determine what type of problem this is, and based on that categorization, we apply the appropriate response. This is the domain of best practices. This is the problem set in which you can safely create and then follow a script anytime you re-encounter that same situation. If you need to change the password on your computer, if you need to figure out how to log your time, basically any problem that the first level help desk at your office could help you solve, these are obvious domain problems. The next domain is the complicated domain. In the complicated domain, we're still part of the ordered systems. There's still a predictable effect to any given action inside of our problem set. The difference between the complicated domain and the obvious domain is that in order to determine what that effect is going to be, you need expertise. For this reason, the approach to problems in the complicated domain is to sense what the problem is, to analyze the problem, and then to respond according to that analysis. In the complicated domain, there's no such thing as best practices. There are only good practices. An example of this might be a broken down car. If you have a broken down car, imagine that your car broke down and you can't figure out what's wrong with it. But there is a discrete reason your car broke down. You might not be able to tell what that reason is, but expert mechanics could. You call in 3 mechanics. Mechanic A might tell you that the solution is to replace a given part of your engine with a new part. Mechanic B might have you repair the part with some duct tape and baling wire. Mechanic C might have you route the engine around the broken part so that it's no longer required for the function of the engine. Each one of these approaches is a valid approach to getting your car running, and based on a myriad other, contextual realities, one of them might be better than the other. The fact of the matter is, all of them are good solutions, and the only wrong way to approach a complicated problem would be to try and assume that one approach is always the best approach. The complex domain is our first non-ordered system domain. It comes from the complex system. And I'll remind you, what that means is that while there is a relationship between cause and effect, and it's a relationship we can appreciate in hindsight, it's not something that we can predict. We can tell that a given action caused an effect, but we can't predict that a given action will give us an effect for sure. Because of this, it doesn't do us any good to try and have best practices to solve a given problem. We can't tell what effect those practices might have. Similarly, it doesn't do us any good to bring in experts and deeply analyze the problem to come up with approaches, because unknown unknowns mean that those experts might not have the information that they need in order to generate a solution that is acceptable. Instead, the appropriate response to a complex domain problem is to probe, sense, and respond. That is to say, you try an experiment, you sense the reaction that the experiment garners, and if it's a positive reaction, you amplify the experiment. If it's a negative reaction, you dampen the experiment. Now, it's very important to properly construct your experiment here. You need to know in advance how you would amplify this. You need to know in advance how you would dampen this. You need to make sure that your experiment is an experiment that can fail safely without things going catastrophically awry. Given that experiment, however, you can iterate over and over again in order to see the solution to your problem emerge. For that reason, this is not the domain of best practices or even good practices. This is the domain of emergent practices. Your activities are going to help a solution emerge. An example of this might be an interviewee trying to get a job. There may well be the perfect thing to say in order to get that job, but you don't know what it is, and no amount of thinking about it beforehand is going to give it to you. No web page on the internet is going to tell you the perfect answer to all of your interviewer's questions. Instead, you're going to make a conversational gambit, you're going to gauge the reaction of your interviewer, and you're going to respond according to that interaction. The next domain is the chaotic domain. The chaotic domain stems from a chaotic system, and as such, there is no discernible relationship between cause and effect. In the chaotic domain, the only wrong decision is indecision. We come into the chaotic domain and we are trying to stabilize a problem. We are trying to get a system back on its feet. We don't have time to look up a script, right? The problems we're looking at aren't problems we've seen before. We don't have time to bring in experts and wait for good practices. We don't have time to experiment to see if we can emerge a new practice to take care of this. In the chaotic domain, we act, sense, and respond. We come in and we act immediately to stabilize the problem. We sense how that's going and we respond accordingly. Because of that, the practices that we're executing in the chaotic domain are novel practices. Our goal in the chaotic domain is to come in and to get out as quickly as possible. An example of a chaotic domain problem might be your production systems going down. When your production systems go down, you want to come in, you want to do whatever it takes to get those systems back up. And when your systems are back up, you may well have a problem that lends itself to a complicated or a complex domain space. You might then ask yourself, how did this happen? How do I prevent this from happening again? But in the context of your problem that exists in the chaotic domain, we simply are acting to turn the system back on. Finally, we have the disordered domain. The disorder domain is a little bit of a special domain because it isn't a place where you find an approach to your problems. The disorder domain is the bucket that you land in when you haven't yet chosen which of the other domains your situation puts you in. The goal of the disorder domain is to categorize your problem into one of the 4 primary domains and get out of the disorder domain as quickly as possible. So there are your 5 domains. In order to execute the Cynefin Framework, you look at your problem, you slot it into a domain, and you know how to approach your problems. Before you get too busy slotting, however, it's good to bear in mind that everybody brings to the categorization process their own prejudices. People tend to be most comfortable in one of those domains, and because they're comfortable there, they see problems belonging there that maybe don't. Administrators, program managers, bureaucrats of all kinds, people who make their living either creating or enforcing process will tend to see failures as failures of process, and they will try and put problems into the obvious domain space where they can define new best practices and new standard approaches to solving those problems. People who are deep experts in a given field are used to thinking of analysis as the solution to their problems. They will tend to see failures as failures of being given enough time or resources to do proper analysis. They will slot problems into the complicated domain, thinking that more analysis, more time will give you solutions, when in many cases that isn't the way to go about solving your problems. The complex space is the preferred space of your politicians and your battlefield commanders and people who are used to dealing with nebulous flowing problem sets. Now, generally speaking, this is a fantastic domain to err towards if you're not sure. Generally, you can iterate towards solutions regardless of whether they would be more optimally solved by pulling an expert in or having a standard that you can look up. The pain point in erring in this direction is that it's generally slower. An expert can tell you a solution potentially much more quickly than you can iterate and emerge that same solution. Similarly, if you can just pick it from a list, that's most efficient of all if you can get it done that way. The chaotic domain is the preferred domain for your dictators and fascist autocrats and people who like to be in charge and do things their way. It's obvious that this can be dangerous to tend towards because in addition to just go, do without the analysis, without the good thinking, you also never flex those muscles. If you're constantly acting without giving time for analysis or pulling in experts or following good standards, you are failing to develop those muscles, and you will tend to have a difficult time leaving the chaotic domain because of the atrophy of those capabilities. Now, bearing all this in mind, you're prepared to pick the domain that your problem belongs in, and understanding that domain, attack your problem appropriately. Another feature of the Cynefin Framework are the boundaries between domains. Now, you might find a problem set that moves between domains. These boundaries are things that you can move between. They allow you to pass. And generally speaking, passing between the domains is not too expensive. There is one exception to this rule, however, and that's the boundary between the obvious domain and the chaotic domain. This particular domain, it's relatively easy to move from obvious to chaotic, but it can be very, very expensive to move from chaotic back to obvious. As an example, you had a problem, you slotted it into the obvious domain, and you generated your script. You created your best practice in order to solve this problem. Over time, whenever the problem or something like it appears, you apply your best practice and you succeed. As you continue to succeed by executing this same script over and over again, you start to be confident, right? You start to believe in your own myth. You start to mistakenly assume that past success guarantees future success. It proves you against future failure. And what's going to happen is you're going to move very close to that boundary between obvious and chaotic, which we call the complacency zone. In the complacency zone, what can happen is that when your script fails to solve a problem for the first time, you fall over and you're in the chaotic domain. You have a problem with a script that doesn't help you. You don't have the discipline to emerge a practice by experimenting and moving slightly, or you don't have the time to spend to emerge a new practice as a complex domain problem, and you've atrophied the muscles of pulling in experts and thinking things through. You have a very expensive time then getting those engines back into gear and rebuilding the discipline of creating either good practices or emerging practices to solve your problem. It's very expensive to self-correct if you fall. Because of that, it's best, whenever you can, to manage your problems in either the complex domain or the complicated domain. In these two spaces, you're either emerging new practices with experimentation, or you're using analysis to create good practices. Only the very safest, very smallest practices should be moved down into the obvious domain as best practices. And even when you move things down there, you should constantly be on the lookout and reanalyzing, making sure that there's still the best practices to solve that particular type of situation. Because in periods of rapid change, when the solution that used to work no longer works, things you've slotted in the obvious domain are very susceptible to tipping over and failing. So, this is the Cynefin Framework. There are lots of resources online if you want to read more, learn more, and hear about different applications of it. For now, though, I'd love to hear what you think. How might you or others you know benefit from using the Cynefin Framework? Do you have any problems, or do you know other people who have problems that might benefit? Please feel free to leave a comment or leave a question if you're curious about anything else that I can help you with. I hope this framework can help you as much as it's helped me.